Welcome to our first Earth Series event of the academic year, and in advance of Columbia Giving Day on October 26th, our annual day of giving to support the work of the Climate School. Tonight we're going to focus on water. It is essential and all-encompassing. It is important for human survival, of course. It covers more than 70% of the planet, and it is at the heart of the climate change-related consequences, from heat and fire, drought to flooding, famine, and sea level rise. Water is a subject of huge scope, grave stakes, and myriad consequences. While all our lives and societies depend on water to survive, water-related risks are actually multiplying, partly because of climate change. These risks and issues are all at the center of the work of my three guests this evening. We will interrogate many aspects of water, from the urgent concerns specific to the United States to global and climate change related issues. So we've got three experts from Columbia to help us address this. The first is Ana Navas-Acian. She is professor and vice chair of research at the Department of Environmental Health Sciences in Columbia's Mailman School of Public Health. Ana is an Earth Institute faculty member who works on the challenges of communities struggling to access safe, contaminant-free drinking water. Manu Lal is the former chair of Earth and Environmental Engineering in Columbia's School of Engineering. Manu also is an Earth Institute faculty member who studies hydrology, climate dynamics, water resource systems analysis, risk management, and sustainability. He is director of the Columbia Water Center, which is another Earth Institute center in the Climate School. And then we have Nay In Eep. Eep is an assistant professor, also in Earth and Environmental Engineering. He is a technology innovator who is also a part of the Columbia Water Center. He works at the nexus of water, energy, and the environment, and he's going to tell us about many of his clever innovations that he's getting into. So welcome to you all. Wonderful to have you here. And to begin, I'd like each of you to tell me briefly about what led you into your area of study. And I'm going to start with Ana. Your work aligns with social justice issues. When did this become a priority for you and your work?
Yes, thank you. Thank you so much, Alex. So I am a physician and a public health scientist. And I really became early on in my career very interested in the role of the environment in human health. And I started investigating how water contaminants such as arsenic, lead, how do they affect really health outcomes. And we found these are really important risk factors for cardiovascular disease, diabetes, cancer, many, many health outcomes, and very often overlooked. Like the clinical community is not paying attention to this or was not paying attention to this. But I also learned that my traditional research tools were not enough. These were very complex issues. They affected some communities more than others. And we really needed to take an interdisciplinary approach. So I became much more engaged in working with other disciplines. And also I got inspired by a particular study, which is called the Strong Heart Study. This is a study with indigenous communities across the Southwest and the Great Plains in the US. And really, I learned many lessons that I had not learned through my research training. And that really shifted completely the way I was doing my work. We needed to do much more than research. Research was not enough. We needed to make sure that the findings of our science could really benefit the people who needed it the most. And so here we are tonight as an example of that, of how we can try to accomplish that goal.
Great, fantastic. Manu, tell us about you. You're director of the Columbia Water Center. You are a climate modeler. You do a vast array of things in climate and water related issues. What brought you to this work in the first place?
Yeah, thanks very much, Alex. I guess it's a cumulative effect of life. I grew up in India and water is everywhere. In fact, if you think about when you're growing up, all religions have water as part of their ceremonial processes. And in every aspect of life, you see that the circulation mechanisms, whether you're in the human body or at the planetary scale are driven by water. So from a curiosity perspective, I think I was there early on. We started the Columbia Water Center in 2008 with a mandate to look at global water sustainability. So I think in the most applied aspect of my life, that's when I really got more engaged in trying to solve water problems. And since then, we have actually worked in all 4 continents with governments, with farmers, and with community members trying to solve these kind of problems. And it's been very rewarding, and I'm grateful to Columbia for providing that opportunity.
Great. Well, we are as well. So, Eep, you're a technologist and you strive to find innovative ways to filter out impurities and contaminants. Can you describe your work and tell us how you got started in this field?
Sure. Thank you to Alex and the organizers for involving me in this today's event. The technical term for the work I do is physical chemical separations. That's quite a mouthful. In layperson terms, it is basically taking stuff out from other stuff. Right? So we're trying to do a separation here. For example, we're trying to take contaminants, impurities, pollutants out from water and make it safe for consumption. Or sometimes you're also taking out the water molecules and leaving the gunk behind. It's not always bad stuff that they're dealing with. Sometimes some of the stuff that we're trying to separate is valuable, something that we want to harvest. For example, there can be precious metals and rare earth elements in what is considered as conventional waste streams. We can try to do resource recovery from these waste streams. As to how I got into this work, like my fellow panelists, I got in the topic of clean water and safe water because of its importance. There is just no substitute for water. And this is unique. This is unlike the other urgent topic of, say, energy. There we have a few more options, right? If we don't want fossil fuels because of the carbon emissions, we move to wind energy, solar energy, hydroelectric, wave energy, or even thermonuclear, which is debatable, but there are options there. There's just no chemical to substitute for H2O, right? This is the one compound that we need. Without it, there's no life, there's just nothing. And I believe that technology has an important role to play in addressing our water challenges. Technological innovations got us to where we are today, from the way back in the days of the Roman aqueducts to the birth of sanitation in Victorian London, to understanding the microbial origins of waterborne diseases, and more recently, modern water purification, disinfection. So technology has carried us a long way, and I think it will continue to play a central role in solving our current and emerging water challenges.
Great, thank you. Well, let's begin with those challenges. We'll maybe get onto climate change a bit later, but there are some pretty amazing challenges just associated with safe drinking water in the first place. So I'll start with you, Manu. Can you describe the problems that have been surfacing here in America, which it seems almost inconceivable that here we are in the year 2022, and we have problems in America about safe drinking water. Can you tell us what are the major challenges here in the US?
Sure. We take pride in America that we have the best water supply in the world. So exactly as you phrased, Alex, it's surprising and challenging that where we are. And I know Anna's going to talk about one segment of that problem, but I'll try to lay it out broadly. We have challenges with quantity, quality, and affordability. So that's in a very small nutshell what we are talking about. Let's start with quality. And I started looking into this about 10 or 12 years ago, specifically because as we were working in developing countries and coming up with recommendations, people were asking if we solve the problem in the same way in the United States. And the answer to that question led me to start looking at what we are really doing here. And what was depressing to see was that we were a country in decline in this regard. We had a situation where we had infrastructure that was designed to be state of the art 60, 70, 100 years ago and was failing today. And the communities did not have the money to replace it. The federal government had not been putting money into it. And as a result, there was a patchwork quilt of water infrastructure that was coming into place. And what that translated into across the board, but more importantly, wherever the communities were poorer or more minority oriented, they did not have the technical or financial capacity to even understand what they were going through. And their ability to get help from the politicians was also limited. So in short, what we see as examples are, there are today 850 main pipes that break per day in the United States. Every time that happens, there's a boil water notice and water supply is not restored for several days. I did not know what 850 water pipes breaking per day means. So I started looking into that, and it turns out that in the 1950s, that was exactly the same number, but per year. So we've had a factor of 300 increase in the failure of primary infrastructure elements in the country. What we see in places like Jackson, Mississippi, which is our latest example, is a system which is in a city that's the capital of a state in the United States, so not insignificant in some sense. 180,000 people who were left without water services for over a month. And so everyone was jumping up and talking about that. And this was somewhat related to climate change just because there was a flood, but there was really maintenance failure of a pump. But when you look into it, they have actually had this as a chronic problem for the last 4 years. And it requires about $1 billion to fix this problem, which translates into $22,000 per family, and the city cannot make that investment. So that's where we are as an example. And this is not the only city. We can run through a large list of these kind of problems. And so to one extent, the problems we face are those of a lack of proper investment in infrastructure. To another extent, it is the profusion of chemicals that we are now concerned about and our inability to effectively treat them. So while we look at those problems, the two other things that I had mentioned were quantity and affordability. So let me talk a bit about those, and then we can summarize where we are. We have the worst drought in a million years, or sorry, in 2,000 years in the American West, according to some estimates. It may be at least 1,000 years or whatever. What this is translating into in a place like Phoenix, Arizona, and its surroundings is that a lot of the communities that are not part of the central water systems that supply them are basically out of water at this point. And they don't have access to alternate sources. People may be surprised to learn that quite a few of the households in the US receive water that is trucked to them. It's not on a pipe system. This is not something you see even in many places in the developing world. So that's a quantity story. Then the affordability story is interesting, that while things are breaking, the cost of water supply has been going up. So it's on average, the water rates have increased in the US in the last 20 years at twice the rate of inflation. And this in many communities is leading to affordability issues. Examples being Atlanta, Georgia, examples being Cape Cod, a rich community, but Atlanta, Georgia, the water bills are around $400 a month, and Seattle is close. So the trifecta of these things reflects a need to really rethink how we should design and operate water systems in the 21st century. The model that we used in the 20th century has served us well, but it doesn't translate into an effective system in the conditions we look at now. And since what we do in the US is followed worldwide, it's critical that we get it right, and hence allow other places which have the same three challenges to function better.
Oh, so this is great. So that's a great way to start with the three big challenges just for America. But tell me a little bit about what you think the solutions are. Tell me about what you're doing through the America's Water Initiative in particular.
Yeah, so when we started looking into this, the number one thing that was jumping out was there is no money and there's an affordability issue. So we've been looking at what are the financial mechanisms that you bring to bear. And we also started realizing that there was a technology issue. So this is an area which is very conservative, so to speak. So what that means is people don't want to change what they do very quickly. What we've discovered is that if we start thinking radically differently and change our aspirations for what people should expect for the same amount of money that they spend on drinking water today and wastewater treatment, we could change the game so that they can expect that when they open their tap, they can immediately get a verification of which chemicals are not there, what has been taken out, or basically assurance that what they are getting actually is safe. Because one of the lessons we got out of Flint, Michigan, which became the poster child of lead in water, was that at the treatment plant, the water quality was fine. It was after it went through the pipes that there was a problem. And it went for 1.5 years before anyone figured out what was exactly going on. So if you actually had an ability to check what was going on at the point of use, it's a different story. So technology has a role in assuring the quality of what you get. That's the first order thing. I have a watch that tells me my blood pressure, my blood oxygen, blood sugar. Where is my watch for my water quality? And that's the challenge that we are putting forward. The second thing is, once that assurance is possible, then any source of water becomes eligible for treatment and use, because it's no longer necessary to send things through a large central treatment plant and then through pipes whose quality we don't know, and then someone drinks it. Because if we could do it locally with rainwater, stormwater, wastewater, it doesn't really matter. That goes through a treatment process. And now it's verified that things are good. That changes the game completely. And so the question is, can you actually do this today, technology-wise? And can you actually do it at a cost that is lower than what is being done today? And from the work we have done so far, the indications are the answer is yes. And so that's one side of the story. And the other side of the story is that, as I think Anna will talk about, many of these communities simply do not have the financial or technical capacity to even lay out what their problem is, far from trying to solve it. So one of the things we are doing with the help of the Columbia World Projects is to develop tools that have a menu of different technological options, and a community could go to the web, put a polygon on a Google Earth map. We automatically pull up all the information on buildings, roads, and soils and climate in that area, and groundwater levels. And across the array of different technologies that are available, come up with a system designed for them, which is spatially distributed. So multiple treatment locations, multiple wastewater treatment locations, multiple reuse locations, that minimizes the overall operational and capital costs for that. The significance of this is that the US government has money that they put out, but it is grossly misused because many of the people who need it the most have no ability to access that. So what we are trying to do is to democratize the access so that these people can actually compete for it. And at the same time, the private sector has now become very interested in being part of the solution. The finance people, as well as their technology companies. And it's the same challenge for them. They don't know where to go, which communities should they try to help. And so what our tool's trying to do is to solve that problem as well.
Brilliant. Okay, thank you. So that sort of segues nicely into Anna's work. Anna, of course, you're working in the realm of health in particular, and pollution and safe drinking water, but you also intersect with the issues of social justice. And so I'd be interested to see how you see this intersection and who is most at risk from water issues.
Yes, so as Upmanu has described, these are many challenges occurring at the same time. And we really need to study and intervene on this. I want to first talk about one of the nationwide efforts that some of our team is leading by Dr. Annie Nigra. She's a faculty member in environmental health sciences. And she took the data that is reported to the EPA as part of the Safe Drinking Water Act. It's very timely because yesterday was the 50th anniversary for the Safe Drinking Water Act. So it's a great day to do this meeting. And so using those data, what she found is that, which very well described in very level of detail, is that smaller communities that are predominantly Hispanic, Latino, or American Indian communities and also communities predominantly using groundwater are the most affected by some of these contaminants, especially the inorganic contaminants such as arsenic, uranium, and others. But not only that, okay, that's in the water, but if you look at the urine of people living in those areas, depending on the water amount of the contaminants, people have much higher contaminations in their urine, around 25% or higher, depending on how we count these levels. And so this is really important. This is telling you these contaminants are not just in the environment. They are getting into the people's body. They are getting under the skin. And this is why we are really concerned about this. And if you think of water as we've described earlier, we all need water. It's your daily dose. You have to take it every day. And you can think of water contamination as in reverse for taking an aspirin or taking your daily statin. Instead of preventing your health and making you have better health, you are getting worse health. So this is real issues. And of course, some of the other issues as described in Flint and many other cities, so many cities affected. This is a real issue nationwide. But we are also very interested in the local aspect, in the rural communities and in the indigenous communities that I mentioned earlier.
So tell us about that. You've done much to study unregulated private wells, which supply many rural populations across the United States. How vulnerable are these water sources in particular to contaminants, and what do we know about the health risks associated with exposure to pollutants?
Yeah, so as the smaller community water systems and the private wells, especially the private wells, they are unregulated. Most often people use them without any information. Also, as Manu mentioned, we don't have an easy way to test at that tap level for multiple contaminants. It's very expensive, very hard to do right now. So this happens in the indigenous communities that we work with, that in the Northern Plains, and many families are affected. Something really good, I want to bring some hope also here, is that there have been some investments in those rural areas. For instance, a new water system was put in place, bringing water from the Missouri River. This is called the Mini-Wichoni. Mini-Wichoni means water is life in Lakota, in the Lakota language. And these treatments are tested, but many families cannot be connected, and other families don't want to be connected. They don't want to lose the independence of their water source, of their groundwater. They like their taste, they like and the temperature. There are many things that they like about their water. So that makes it even more challenging. How do you really bring attention and to these communities, and how do we help respect those community wishes and knowledge and that understanding of what so this is important, and we really are working with our community partners to move that forward.
So do you think there's an underappreciated danger I mean, climate change is all about surprises and shocks, and do you believe there's something that we actually need to wake up to that could happen in underserved communities?
So I think for decades, I mean, for such a long time, there has been so little interest, investment, and that has really contributed to leaving many communities behind. And you can explain this by the way our system operates that favors racism and classism. But some really good movements have happened in the US. And these are grassroots movements that have really moved environmental justice forward. And in the last few years, those movements have really attracted policymakers, investors, and that I feel it's a moment of hope also. And one of the key elements that, again, earlier I talked about changing the way we do research. And I think one way that has really been impactful is by bringing in participatory methods. and to make sure that scientists, engineers, when we develop this technology can be amazing, but we need to make sure that they can really be effective locally, that the communities can really embrace it, that they can contribute to the development. And so this I think maybe I am optimistic, but I perceive a change in attitude with respect to these participatory approaches. I think we all understand we failed quite a bit, and we are failing, and that if we really want to make real change, we need to take that participatory and that community-centered approach.
Great, fantastic. Eep, let's turn to you. What do you see as the most urgent water-related risks that humanity faces right now?
So I think the point I want to make here has been touched on by Anna in her response. I think the growing water inequity between the haves and the have-nots, I think that is probably the most urgent water-related risk facing humanity. And I think we need to be reminded that that clean water and sanitation have been recognized as human rights by the United Nations General Assembly since 2012, so a good 12 years. And this means rights for all, not just for the well-off. Now, there are countries such as South Africa where the right to water is enshrined in the constitutions. Unfortunately, that's not the case in the United States, and probably with our political deadlock, that's not going to happen anytime soon. And it's also unfortunate that it tends to be the poor and underserved communities of the world in the US that bear the brunt of water scarcity and impurity problems. We see this in Jackson, Mississippi, that Manu talked about, in Flint, Michigan, United States, and all over the world. And I think technology has a critical role to play to address this water inequity. A lot of the water problems we have actually have solutions. Now, the sad thing is that not all of these solutions are readily affordable. Right? This is one of the three points that Manu brought up earlier. It's quantity, quality, affordability. We need to address the affordability issue here. So I think we need to innovate new technological solutions that are more accessible. And I think there's perhaps a mistaken perception here that high tech may necessarily mean high cost. That doesn't have to be the case. Innovations can drive sustainability, it can drive affordability and affordable access to clean water.
So you work at the intersection of water, energy, and the environment. So that's interesting. And other people talked about water, energy, that nexus. Can you elaborate more on this and what it means?
Sure, I'll be happy to. I think when we mention water, energy, and environment, a lot of time, people would think of this as separate, independent issues, but in reality, they are very much interconnected, very highly interdependent. They're almost interwoven into one another. Now, there are many examples of these interwoven relationships. I can illustrate using an example from an area we are working on. Now, one of our thrusts of our research agenda is to apply the principles of green chemistry and engineering to water treatment. And here we are pioneering a technology that utilizes suitable solvents for desalination. Now, this innovation, this approach is radically different from the prevailing methods that we have that's based on evaporation of water or membranes. The technology that we're pioneering uses a recyclable solvent to extract water out from brines, and then by applying a moderate thermal trigger, we release the desalted water. So now we are basically using the suitable solvent as a sponge. We sponge up the water, and then we later release the desalted water. And the energy input here is just a mild temperature swing from ambient temperature to maybe around 60-70 degrees Celsius. And so we've demonstrated that this technique is able to de-water hypersalinite brines. They are not readily treatable by conventional methods. And an important thing here is that we're able to utilize quite affordable energy sources such as low temperature solar energy. A perhaps surprising application of this technology is in the American West. Now, in the American West, in places like Arizona, Texas, groundwater is a potential source of water. The groundwater, however, contains some salts. It's not a lot, but it's considered brackish water, right? So it's not suitable for direct consumption. There are existing methods to desalinate this brackish water and produce fresh drinking water. right? But after we do that, we're still left with a very salty brine concentrate. Now, it's important to be able to treat or dispose of this salty brine concentrate, otherwise it becomes an environmental issue. So here, this is the connections of water to the environment. And if we're not careful, right, it can lead to environmental disasters, hazards. The treatment and disposal of this salty brine can be very costly. We do not have good technologies to do that right now. So what that means is that now the whole concept, the whole approach of using groundwater for our water supply, everything becomes uneconomical. So this is an example of the water, energy, environment nexus. A water issue here is connected to energy. The high energy cost of treating the brine concentrate is connected to environment. The improper discharge of brine concentrate is environmentally hazardous. Now, the technique that we are developing can potentially unlock huge supplies of this groundwater by dealing with the hypersalinite concentrate in an energy efficient, cost-effective, and sustainable manner. There are many other examples. Perhaps I'll have an opportunity later on to elaborate on more such examples.
Okay, so what do you see as the greatest challenges for the United States in particular? We'll move on from the United States, but right now, it's such an incredible situation we're in. What do you think are the biggest challenges we face?
Now, drinking water and wastewater infrastructure is designed to last for 40, 50 years, right? So this was done in 1950s, 1960s. Most infrastructure that we have right now is well over their lifespan. It's not surprising that they scored C- and D+ respectively in the American Society of Civil Engineers 2021 report card. Now, I would propose to flip the challenge around and instead think of it as an opportunity. We now need to renew our infrastructure. Do we want to replace them wholesale, right? Just take whatever we have, build new ones and put them in direct substitutions? Or do we want to seize this opportunity and modernize our drinking water and wastewater infrastructure? In the past 40, 50 years since we built those water and wastewater infrastructure, science and technology has progressed tremendously. Given what we know now, we should be seriously thinking about putting in the best innovation, the best technology, the best approaches that are effective, cost competitive, flexible, resilient, reliable. In other words, how do we future-proof our water infrastructure for the next 40, 50 years and beyond? And that might mean moving away from centralized water treatment. We need to think about sensors, as Manu mentioned. Perhaps we need to think about point-of-use water treatment. So all these options should be on the table, and we want to apply the best science to address these challenges and really plan for the long-term future. We do not want to kick the can down the road and have to deal with this 20, 30 years later.
Sure. Manu, let's get back to you. This is great. Thanks a lot. Manu, let's talk about climate change a little bit, and in particular, what climate-related water issues you are most concerned about in your work. How do you see climate actually intersecting a lot of these issues and other ones related to water?
Yeah, I think, water is central to climate and climate is central to water is unfortunately the situation. It's obvious, floods, droughts, increased pollution. These are all sensitive to climate trajectories. The biggest concern I have is that we are going to be radically unprepared for major climate-related disasters coming up. These are flooding. And one of the things that I'm concerned about in the US context, but it's a global concern, is that we have a lot of large dams that have been built over time. And similar to what Yip was saying about the other, drinking and wastewater treatment infrastructure, these dams are well past their design age. The largest flooding disaster in the United States ever, in terms of loss of life, was a dam that failed. It was not a rainfall event. What we are looking at now is that recent failures of dams in the United States that have happened, with the exception of one set of dams in South Carolina that failed in a 500-year rainfall event, the others have failed with relatively moderate rainfall events, persistent but moderate rainfall events, not particularly extreme. So if we have some extreme persistent rainfall events, which we fully expect under climate change, we could have a massive dam that goes. And one that almost did in 2017 was Oroville, which is the tallest dam in the United States in California. If that had gone down, first of all, they evacuated 200,000 people in time, and luckily nothing happened. But if that had gone down, the water supply for half of Southern California, half of the water supply for Southern California vanishes with that. And you would have had major impacts all the way from Sacramento to San Francisco. So this kind of thing worries me because it's flying under the radar. I had a chance to talk to the Congressional Water Resources and Infrastructure Committee on this topic. And they said, oh, we know about this. We are putting $3 billion together for this issue. So my reaction was, oh, that's good. I didn't know that. And then a woman who was there said, you should tell him that that's over the next 30 years. Now, that's interesting because that goes nowhere because the repair of Oroville cost $1.2 billion as it is. So yeah. I think, those kind of things are really scary and we have to think about what to do. What happens with sea level rise can be viewed as either a persistent nuisance that people will have to deal with or a catastrophic failure of a wide variety of infrastructure ranging from wastewater treatment plants, water treatment plants, and energy infrastructure and transportation. So I think we have a pervasive impact that comes from those. The drought issues are equally significant, but there, I think, the answer perhaps is migration. There will be various activities and humans that will migrate out of those areas. But with catastrophic failure of dams, levees, and flooding, there's not an escape because these things work on a different time scale.
Yeah. So, I mean, I would imagine there are a lot of issues when it comes to the drought in Southwest where people are going to have to use water differently, fundamentally, because actually there's a, in particular, the amount of water that gets used for agriculture, or maybe use different water for agriculture or whatever it is. There's got to be solutions to deal with this that are going to have to involve change. And migration is a sort of a massive issue. So it doesn't feel like a solution. It feels like a huge problem that we're going to have to deal with as to how we do that and what are going to be the rights of people who actually have to move away from their homes because they've got to go live somewhere else. I mean, this is something we haven't really had to think about in the context of the United States very much in the past, but it's going to be an issue around the world. Anna, maybe I could switch to you now. What do you think of as the most, we know the most climate change related consequences fall on those who are least able to deal with the impacts and have been least involved in actually causing climate change. How does your work deal with this part of the water story?
Yes, so this, for me, when I think about climate change, I immediately think about indigenous communities. Because, as you were describing the issues in the Southwest, we have most of the indigenous communities in the US live in the West, in the Southwest, but also in the Great Plains, which are also similarly affected. And something that these indigenous communities have been, and elsewhere in the world, have been worried and concerned about climate change for a long time. I would say probably they were some of the first kind of large communities to really thinking about this, also because they were very, very closely affected. But something I like to think about this form of traditional knowledge that I've learned from indigenous communities called the 7th generational principle that I think is very relevant to our society today. And this means that when we're taking decisions, now thinking about solutions for water and the technology that we put together, how is it going to affect the communities, but not only today, also the idea of 7 generations down the road. And I think this principle, it helps to understand why kind of indigenous communities serve as safeguards of our natural environment, of our water resources, of those coming behind us. And this is a principle that I really appreciate. And but unfortunately, these water drought issues, the water scarcity, these are real issues that are affecting us today, not just 7 generations down the road. So I think we really need a lot of work in this area. And from our contaminants perspective, we are also wondering, and there is evidence that this might also impact the levels of the contamination. So this is really a lot of work needs to be done in this area.
Great, thank you. Eep, I was wondering if you could tell us a little bit about how your work in particular, when you talk about energy, how does your work address climate change and sustainability?
Yeah, so as I mentioned earlier, water, energy, environment, these are very closely interrelated, and we can further throw climate into the mix as well. Can illustrate this with an example of the nexus. Now, lithium, we know, is a critical material for energy sustainability. We need it for our battery in order to actually achieve climate solutions. The one way to produce lithium right now is from subterranean brines, brines that exist in the ground. Firstly, the huge amounts of water is needed to pump into the ground and push the brine out. Now, in many places, such lithium mines are located in arid, water-scarce regions, such as the lithium triangle of Chile, Argentina, and Bolivia. So already we need water just to get the brines out, and then to produce lithium, we need to evaporate off the water from the brines, really further concentrate the brines, and eventually precipitate out the lithium minerals. So in the prevailing production methods, this is achieved by solar evaporation ponds, where huge areas of land basically being the brine being spread out over these huge lands, and we're waiting for the sun to do the work to evaporate the energy. Now the energy eventually is coming from the sun. So now an energy issue, which is lithium for energy storage, is actually a water issue, right? Firstly, we need water to pump the brine out, and then we need to take the water out from the brine. And it's in turn an energy issue. We need this solar energy input. To meet our climate goals by 2050, the estimates for lithium production is that we need to increase that by approximately 500%, right? So 5-fold increase in the lithium production. There's one estimate, some of them go as high up as 8 times the current production. Now we cannot really speed up solar evaporation. That's just one sun. So we need to think of more engineered approaches. And this is where our technology come in. We want to remove water from the brine with higher energy efficiency. We can speed up the process. And right now, these brines are technically difficult to deal with. The industry doesn't have good approaches to do so. What they have right now are very costly, which is why we resort to solar evaporation, right? We're just spreading them out over relatively cheap land. And this is the innovations that we're pioneering that allows us to, well, firstly, to concentrate the brine, remove the water, and also allow the water to be reused. In solar evaporation, the water evaporates, or we lose that water, but we need to be able to reuse that water, and it's important because we are the current production methods for lithium, they are competing with water from the local populations. They're basically taking water away. If we're able to reuse that water, we close the water loop there. So solving the issue of lithium-rich brine addresses energy sustainability, addresses water scarcity, and more broadly, touches on the climate crisis as well.
Okay, great. Anna, let's get back to you. You've recently been named as director of an exciting new program, which I know a bit about, of course, because I'm involved, the Superfund Research Project, which is studying geochemistry and health effects of drinking water contamination. Can you tell us what you will be looking for? And does this have the potential to lead to real solutions?
Yes, so one of the communities that we are working with for this new program, this new center, have been affected by abandoned mines, abandoned uranium mines, and which are very common. There are lots of abandoned uranium mines across the West, and many tribal communities live nearby. And so we have developed this idea of interdisciplinary that we've been talking from the beginning, working together with the Climate School, Lamont Doherty Earth Observatory, the Mailman School of Public Health, and with this, very importantly, with our community partners in the Northern Plains, in North and South Dakota. And our goal for this project, there are lots of people involved, and our goal is to advance science and technology using these interdisciplinary methods, but participatory methods and local knowledge, the traditional forms of knowledge. And so we work with a local organization, which is located in Eagle Butte, South Dakota. This is an American Indian-owned organization, and the staff is more than 85% indigenous. And together we are trying to answer questions that are very important for the communities. And one of the questions they have is, why do we have these contaminants in our water? And are these contaminants coming from the mining? That's something for them very important. Is the contamination coming from the mining? And we are really excited to develop a collaboration with you and other collaborators across Colombia with expertise in the metal isotopes. It's so exciting that we can maybe learn something of where this uranium is coming from. And we can measure it in the water, and we can measure it in the people also. And so that's been an exciting project. But solutions is what we are looking for. Solutions is the hard part here. And so we are also excited to work with Ben Bostic, from a research professor at Lamont. And he's really, one of the issues we have in these communities is that if arsenic is in the water, that's relatively easy to address. And there are lots of systems in place that can treat arsenic. But if we have uranium in the water, and actually we have uranium, we have manganese, we have selenium, we have a full mix of toxic contaminants. And that's not so easy to address. That's much harder, especially if you want to preserve the taste of the water and keep water that people want to use for drinking and cooking. And so that's Ben is developing this new technology, looking at light-based and microbial batteries, and we are very excited about that. But the most exciting part is that Ben, again, is not working alone from his kind of, earth sciences engineering side, but he's working locally with the communities. And we want to help that technology development and that building capacity locally. That is not just here at Columbia, the scientists do things. No, we want to do it together. And our hope is that maybe we can bring some economical investment later on, or develop the technology to be able to be a kind of put together in place over there. And that's really exciting. So we have a kickoff event to launch the new center. It's going to be December 13 in the afternoon at the School of Public Health. And our community partners are coming. They are very excited to come to New York. And we are very, very excited that they are coming, and everybody is invited. Please, anybody listening today, join us on December 13. Sorry that I brought in this announcement. Sorry for this, Alex.
No, it's fine, it's fine. Okay, look, we're running a bit short on time because we want to have audience questions in about 5 or 10 minutes. So I just the next question I think needs to be if you can be fairly brief. But basically, what do you think, given the multiplicity of problems here and their interconnections, how do you connect the dots and actually identify what needs to happen most urgently to avoid the most dire outcomes? And I'm going to ask each of you in turn. I'll kick off with you, Eep. What do you think?
So I think we need to be proactive here. We need to invest in our research now, invest in our people. We need to train our future scientists, our future engineers. We need to look at solutions across the entire spectrum, and this includes policy, socioeconomic, and of course my personal bias would be technology as well. We cannot afford to kick the can down the road. We need to build up our toolbox and be ready. Some of these challenges are going to come at us hard. We do not have the luxury of having 3 years, 5 years, 10 years to come up with the solutions. We need to act now.
Anna, what about you? What do you think?
I totally agree with Yip, and I would just add these toolboxes, I think I am repeating myself, but doing it together with community partners to make sure they can be embraced locally.
So what are the barriers that are stopping this happening?
Yes, so the barriers, I think, one is the issue of trust. First, do communities trust scientists? Do they trust engineers? Do they trust the policymakers? And for instance, one of the issues is the lack of trust in the government is a major issue for tribal communities, for instance. I think academic investigators, we can facilitate that communication, make this communication work between government and communities. I think we have a privileged situation because we have a little bit more freedom and the government is very tight in many ways. So hopefully that help, if we can help in that way.
Did you say the government is very tired or tied?
Yeah, I think it's
probably pretty
tight in many
tired.
ways. It's tight, both of them, maybe.
Yeah, right. Got it. Okay. So, I mean, I think one of the last things, I mean, maybe is, you know, in particular, which projects do you think would benefit most from financial support? And I think, you know, I'd be interested in hearing from all three of you on that as to, are there particular things you think there should be, people should be putting money into as innovative projects? Mano, Eep, or Anna, what do you think?
I guess I'll attack that a little bit. There's the fact that water is such a pervasive issue makes it a difficult question to answer. And I think I'll stay with the thought that I seeded earlier, which is that we should use the US as a demonstration project for the world rather than talking about solving a problem here and there. So in that sense, one of the, you know, and one of the things that I concluded after doing a deep dive into the technology platforms, the financial issues and so forth is that we really need different kinds of prototype examples to be demonstrated in this country, and then back that up with analytical tools that show how you can scale this. Because in the absence of a demonstration, it's not easy to talk about this is the solution. And there are many levels of the spectrum. Ignoring the government organizations is not useful because they are actually there to provide these services. So we have to embrace them. The same is true of the private sector. They are there to provide these services. So one of the things that I've been thinking about, and we have some traction on, is that we develop a brand new city or community which demonstrates how we can have a high quality water and wastewater services with the goal that across that community, we'll end up with a net zero water, net zero energy strategy. And this is actually feasible, but if we consider a commercial residential development in conjunction with a residential development, because that gives us a lot of surface to capture rainwater and to also have green space where we can embed treatment systems so that we have a recirculating system while using groundwater storage. So we've been thinking about doing this as an example in Texas, coupled with affordable housing targeted at Mexican immigrants who currently do not have any of the water services or the housing. But the important thing here is that this is a mixed use development, because without that, it's not affordable and it's not scalable. So that's one example. And this would bring together state-of-the-art technology, state-of-the-art machine learning and analytical tools to assure that something like this works. And of course, the interaction with the government agencies and the private sector as well.
So I want to skip on a minute and just ask each of you. I mean, I think some of the take-homes I've taken from this, you know, the idea of a big demonstrator project for the United States, I think, is really massive. The future of cities are going to have to be rethought anyway with climate change, and this could be a key part of that, how you build sustainable cities. But I'm also very aware of what we've talked about. You know, you've highlighted the importance of innovative technology, and that is going to be such a massively important thing to actually make progress in this area. And Anna, I really like the way you talked about communities and bringing in communities, and you know, the way you are looking for support, for engagement from anybody in the audience who wants to get involved. I think that's just a great way of thinking about the climate crisis and environmental problems more generally, because in many cases, it's not just that we're looking to help other people, they're going to help us with our work by getting involved. So this has been a sort of great mixture of interplay of messages. I just want to finish before we go to Q&A with the audience. Just very quickly, if you could each give me one really important take-home message that you'd actually like us to address. I mean, what would you think? What if you could do one? Ask people to remember one thing from tonight that's really important. What would it be? So, Anna, why don't I kick off with you?
So I think for me, it's really look for those solutions that communities can embrace, adopt, implement, contribute, so that we can make them really effective.
Great. Eat, what about you?
I'm going to try to cheat and squeeze in 2 points there. Water, energy, environment, and the climate, they're all interconnected. They're all at a nexus, and technology has a central role to play in addressing all these challenges.
Great. Manu, what would be your one take-home message?
Yeah, so I'm going to piggyback off of Yip's comment earlier on opportunity. I look at Mexico City as a gigantic opportunity for demonstrating how something that is completely messed up with regard to water and climate can be turned around and created into an example of where we can solve flood control, wastewater, and drinking water and agricultural water all in one shot. And we've been talking about that for a while, and I think we may be able to do something about it.
Okay, so this is great. So thank you, all of you. Let me just quickly turn to the audience questions. So, and we've had, a lot of questions already, and we can keep sending them in. So we've got some people who are triaging some of these questions for us. And the first one that comes up is something about sewage. There are communities that operate sewage treatment plants while pursuing partnerships with clean energy producers to use wastewater to fertilize algae and other biofuel crops. Are such holistic management policies really catching on? Who wants to tackle that?
Okay.
I think they're starting to gain traction. I think we need to explore all options available, closing the water loop. And in the wastewater, it's not just water itself. There are nutrients in there, and those nutrients are valuable input resources for algae, for example, if you want to think about biofuels. So we need to explore all different options. I think that is definitely benefiting from having more people interested in it. From just a purely scientific, the thermodynamic standpoint, it is possible, right? This is an idea that makes sense. We need to address the technical challenges along the way to make it a reality.
Okay, great. There's another question here. Which US communities are examples of leaders in being innovative in developing future sustainable water resources? Manu, do you want to take a crack at that?
Yeah, there's so many examples there. You know, I'm going to start with Tampa Bay Water. They were one who had to do this. Milwaukee, Wisconsin, Cincinnati, Ohio, New York City in some aspects as well. And if people look at green infrastructure for stormwater and things like that, Philadelphia to an extent. So there's a lot of communities that are actually doing things. The big point here is that if you are financially affluent city, you'll see a lot of innovation and positivity. But if you are not, then it's very hard.
I would like to add also at the state level, New Jersey is a great example of passing legislation and support for private well users. And they've been really at the lead in that area. So private well users, as we talk, they are not regulated, they don't have any help. But in New Jersey, they put a law in place so that the water can be tested and families can be helped with zero interest loan to fix their water. So I think there are examples out there of how great work is moved forward.
I think that's great. So the next one is more of a moral question, sort of ethical issue and human rights issue. Availability, access, and scarcity of water are pivotal to diplomacy and social power dynamics. how do we begin to grapple with pre-water rights, and how does access to water or impose constraints on access relate to fundamental human rights and cultural, natural, and global security implications? We've just seen energy weaponized, so maybe people start weaponizing water. Anybody want to take a crack at the issue of how
Sure.
we look at this?
I'll give an anecdote. There's been efforts to use cloud seeding to produce rainfall for a long time. And
You say cloud seeding?
cloud seeding.
Yeah, right.
Yeah. And the state of Utah had such a program for a long time. And they were spending quite a bit of money on it. And they claimed that it was producing more snow in the winter, which helped the water situation. Then the state of Wyoming, which is downstream of them, said, "You are stealing our water," and sued them. And Utah immediately declared that that program had never worked. So I think this idea of having water rights before the rain even comes down, I think this question is coming because there are now people who want to argue that they're going to harvest atmospheric moisture. This is not different from people who've been trying to do rainwater harvesting. And in many states in the US, that was not legal because that potentially violated somebody's water rights, but that has been changing. The other way to look at it is that as far as water rights are concerned, they are a property right. So if someone has managed to get some water rights before, the question is, what do they do with it? And how do they use it? And how do they sell it? That's completely separate from the human right to water. The human right to water is encapsulated in many agreements, but not in the United States. The United States has resisted having that. California is the only state in the US that has actually acknowledged a human right to water. So what that practically translates into in most places is for drinking water and other uses that are basic, you should be able to get that at an affordable price. For agriculture, you should be able to get support for irrigation water so that you can have subsistence agriculture. So I think these are fairly well-defined issues at this point.
So, I mean, this brings us on to, there's a lot of focus, and of course, we've talked a lot about America. I actually like to see if we can get some questions about the rest of the world at some point. There's a ton of questions just coming on California. So one of the questions is, will there be water wars in the Western United States? You can see like Chinatown, it was a great movie. Anyway, the whole idea that you can actually utilize water in an aggressive way between different states or a competitive way between different states seems a bit bizarre, but it leads to another broader question of the California as the state with the largest agricultural economy. A lot of the water is pulled from aquifers for drinking and irrigation. What are the consequences of prolonged drought failing to recharge those aquifers? Because it'd be, I mean, the California problem is really fascinating, really, because it's the agricultural sector is not by any means the biggest part of California's GDP, and yet they take by far the most of the water. And are we going to end up, basically, deciding who gets the water on the basis of GDP and those kinds of issues? Anybody want to have a go at that? Those issues?
I've been working on this for some time, and so maybe I could take a crack at it. Look, the thing is that the water rights structure is what comes into play here, because it's use it or lose it is the way the water rights are structured. California introduced a water bank where the idea was that if you have surplus water, you would not lose your right if you contributed it to the state water bank, and you would be compensated for it. So there's been a little bit in that sense for some time. But agriculturally, what has happened in the last 20 years in California is that there's been a significant shift from high water using low cash value crops to much more efficient agriculture of very high value crops. And where that has happened, those areas are now asking the question of, are we going to get shut down after we have made these significant investments? So that's the new challenge that community is facing. And the groundwater use that is supporting them, if the drought continues, which it very well might, will lead to more drops which will lead to more land subsidence, which means that when the next cycle comes, where we actually expect major flooding in California, then that flooding will be endemic. It will not be easy to dissipate that water that is part of that flood because the land has settled. So that's the catastrophe that we might be looking at through these cycles if the current trajectory continues. California has dropped around 12, the central part of California has actually dropped in elevation about 12 meters since 1920 because of the groundwater pumping. And then it was arrested for quite some time under federal rules. But in the last 20 years, the drought has led to an increased extraction again.
Okay. So a few other questions for a variety of sources here. So let's get back to lithium and you know, all those good juicy things we need for climate change. The new, if you like, the new oil that we're going to be thinking about, countries with resources. But there is this great connection that you brought out between these extraction of these metals, whether it's lithium or copper or rare earths or whatever, and water utilization. And I was wondering if there's going to be a sort of how are we going to deal with the fact that many of these are located, probably because they were found in hard to get to places, otherwise they've been mined a long time ago. They're actually in places with water shortages. And so how do you see this playing out in terms of the issues of water security going forward?
I think that's one of the issues forefront that needs to be tackled. I think the example of the lithium triangle in South America, that is in a very arid, dry place. And right now, what some of these lithium mines are doing, they're actually pumping water from far away, as far as the ocean. They're pumping them hundreds of miles, and that is very energy intensive. And they're using the seawater to pump out the lithium brine, and after that, they're letting the water evaporate. So we have huge amount of water being moved, and all this water being lost to the environment as moisture. So that has got to change somehow. The mining industry needs to evolve. I think it needs to move away from what we conventionally think of as mining, the miner going in and chipping away at rocks, and think about what does it mean for mining of the future. Can we make mining more sustainable? Can we integrate good water management into mining? Environmentally responsible, socially sensible practices, and all that are things that people are starting to look at. And I'm hopeful that that what is probably an industry that does not have the best reputations will indeed evolve and catch up with the times, perhaps. And I'm hopeful that in the future we will see more sustainable mining, more environmentally responsible mining.
So I have to jump in. Sorry, Alex, if you don't mind.
Go ahead. Sure. Go ahead.
You know, I work with metals. This is the health effects of metals, and because we are mining these metals, we are distributing them all over the earth. You know, we would not have lead as the huge problem that we have today if we had not taken lead out of the ground. And the same with cadmium. And so I am really worried about mining. I think we all have to be, and it seems that we need that lithium, but I don't know, we need to think of this 7th generation principle. We need to think of what are the implications of taking all that lithium out. And I think we need to do it very carefully and very, very as well as possible. I get nervous actually when I hear these things.
I mean, I feel I don't know. I'm not an expert on any of this, but you know, desalination can't be that great either. Is desalination a realistic option for California, or is this something that because you're going to have a lot of briny stuff to get rid of there as well, and you think that can't be good? But who's the expert here on desalination?
I can take that from the technology standpoint. So desalination is probably the most costly way for us to get drinking water. Right? We should consider every other source before we look at desalination. We should look at surface water, we should look at rivers, lakes, groundwater, and we should look at wastewater reclamation. Right, the water that we send to a wastewater treatment plant, we treat it, remove the contaminants, remove the organic matter. The water that comes out from a wastewater treatment plant can be quite readily purified to very high quality, even drinking water standards. And they're doing that. An example would be Orange County in California. The water is potable. It meets all drinking water standards. But because of the lack of social acceptance, they do not do direct potable reuse. They do not connect the recycled water into our drinking water pipeline. Instead, they use that water to do aquifer recharge. And the idea is that the water mixes with the nature, and then a couple of years later, we draw out the water that has been treated, and that goes into our drinking water. So that's known as indirect water reuse. And that is something that we should really consider to expand our water supply. Desalination, we can think of it as a last resort for drinking water. It's the most costly, and there's science can bring us quite a bit in terms of lowering the cost, but there's still underlying physics that governs how cheap they can go. Right? This is the principles of thermodynamics. Desalinating seawater is still going to be the most costly. Now, the good news is that we have the science, and our understanding of handling the brine has actually advanced to quite an advanced stage. When we do seawater desalination, there are engineering approaches we can put in to minimize potential disruption to the ecology, to the environment when we do this brine discharge as brine diffusers, for example. Now, the environmental impact will never be zero, but we can mitigate and really minimize the detrimental effects there. However, in the absence of everything else, right, desalination is really the one option that we can rely upon to increase our water supply. There's plenty of water in the oceans. There's only so much water in the lakes, in the rivers, and underground. We have practically an inexhaustible supply of water in the oceans. So that should be the way I think we should think about this as desalination as a last resort. In certain places, it makes sense. In a lot of places, we should exhaust all the other options first before we finally turn to desalination. And we see this in places like, for example, South Africa, in places like Australia. They have exhausted all the other options, and desalination is the only way they have to turn to in order to meet their demand.
So there's actually one question here. I mean, it's with climate change related crises developing around water. Are there any efforts as a result of climate change to use melting of glaciers or polar ice as new sources of potable water? I must admit, I see this as not something that seems like a horrendous thing to be happening anyway. But anyway, so what do you think the answers are to that? So anybody got any suggestions about? I mean, the main problem we've got right now is the glaciers are melting. So, these places are going to be out of water soon as a result of what's happening in the Himalayas, etc. Maybe not.
No, actually, I will try to correct that. This is a common misconception that the glaciers actually running out will impact water supply, because the glaciers contribute a negligible percentage of water in the rivers are coming off of the Himalayas. If they did contribute a significant amount, they would have disappeared a long time ago. So most of the water comes from the monsoon, and second from the snowpack in the winter. The glaciers are a tertiary source in that sense, and they're somewhat important in the dry season before the monsoon, but even there, they're not significant. But what I think is the biggest concern I have with the glaciers melting is that there is a propensity of glacier lake outburst flooding that can happen, because as the glaciers melt, a lot of solids are mobilized as well, and then they end up damming the channels. A natural dam forms, and behind that, water builds up, and then it can spontaneously fail, and that could be a catastrophic impact. And this kind of thing has happened in Latin America, in Asia, and in Europe as well at different scales. So I think that's a big concern. Now, in terms of can you use this water, I've jokingly said yes in the past, but I think people are already using it because they use whatever comes down the mountain, and they're not particularly thinking about it beyond that.
Okay, we're going to have to wrap this up, but I want to just, so this was great. There's loads more questions. I'm sorry we haven't got time to answer them all. We've already gone on for longer than we normally, than we used to go on, because we wanted to get a thorough discussion of this subject. I'd like to thank Anna, Manu, and Eep for a really fascinating discussion, for bringing their expertise to bear on this issue. Thanks to all of you for joining us, and also for throwing some interesting questions our way. It's really good. I wish I could see you all and we could interact in person, but I have to say, being able to reach so many people has been a great sort of blessing that's come out of the pandemic. Climate change and the work of creating resilience and sustainability requires completely new ways of thinking and new forms of scholarship and knowledge. And I think, as we've shown today, there's an interconnectedness between a number of facets, including health, technology, human rights, issues around what's happening in terms of the natural behavior of the systems that we're looking at, the geosciences. These are all interconnected issues, and that's why you need something like a climate school, which we built at Columbia, which aims to bring all these things together so that we can tackle things in a new way and figure out effective solutions to the threats associated with the impacts of climate change. It's a really urgent mission. I hope tonight's discussion illustrated it nicely. We'd like to ask that you consider supporting our really vital work by making a gift in celebration of Columbia Giving Day, which is next week, that is on October 26th. Your gifts make programs like the Earth Series possible, and we thank you. And they also lead to directly to new knowledge that we're creating. Simply stated, when you support the Columbia Climate School, you're supporting the future for people and life on Earth. So I'm Alex Halliday. Thank you again for joining us. We hope to see you next time as we continue our Earth series. Good evening. Thank you.